In this video, we are going to look at connected bodies, how to solve a problem on connected bodies. So first we need to understand what's the meaning of connected bodies. Connected bodies means when you have more than one object and it's connected with the help of a thread. So you can see that there is a thread which is used here to connect the two objects. We can have different cases of connected bodies, but in this particular problem we are going to see one object placed on the horizontal table, like this one. This is placed on the horizontal table while the other object is hanging. So let's read the problem here. An object of mass 10 kg rests on a rough horizontal table and is connected to a table that passes over a pulley that is then fastened to a hanging object with mass 20 kg as shown in the diagram. The coefficient of kinetic friction between the block and the surface is 0.2. Problem is asking you to draw a free body diagram. It's asking you to calculate the frictional force on the block, because we said that the block is placed on a rough horizontal table. It's also asking you to calculate the acceleration of the system and find the tension in the string. So let's see how to solve this problem. So we have got the diagram and we are going to label the acceleration. Based on our practical observation, we know that the 20 kg mass is going to move downwards, and therefore you can see the acceleration is labeled downwards. Obviously the 10 kg mass is going to move right, and hence we have marked the acceleration towards right. Now we are going to draw the forces on each object. There will be a normal force on 10 kg which will act upwards. The normal force because of the surface. There will be force of gravity which is acting downwards. There will be kinetic friction because the object is moving towards right. So we are going to have kinetic friction which is towards left. And for 20 kg we have got 200 Newton force of gravity acting downwards. And for both the objects, because they are connected with the help of a string, there will be a tension force which is acting towards the pulley. This is the pulley. Now we are going to redraw the free body diagram for each object separately, so that we can see what are the forces acting on each object separately. Now we will take the objects separately with their forces and we are going to apply Newton's second law. So for the 20 kg hanging object, it is going to move only in the vertical direction. So we have got sigma F equal to MA, 200 minus T equal to 20A, whereas for the 10 kg mass, we have got both horizontal and vertical motion. So we are going to start with horizontal. Write the Newton's law, sigma F equal to MA, and that will be T minus Fk equal to MA. And we are also going to write in the vertical direction because it moves in the vertical direction as well. So in the vertical direction, again we write sigma F equal to ma. In the vertical direction, the object is not moving, so you can see that the acceleration is 0. So the right hand side of the equation will be 0. The left hand side is the net force in the vertical direction. We can see there is Fn acting upwards, 100 acting downwards. So Fn minus 100 equal to 0, and we get Fn as 100. We will also apply the formula for friction, because if you remember, the 10 kg mass was kept on a rough horizontal surface. So for friction we have the formula mu Fn. Mu was given in the problem, which is 0.2. Fn we calculated just now, Fn is 100. We substitute that, we get the value for Fk. Now you can see that in this equation we have got Fk, and hence we can substitute the value of Fk, which we got as 20, and we get an equation T minus 20 equal to 10A. Now we have got two equations with two unknowns, that is T, the tension force, and A, the acceleration. And we can solve them to get the value of T and A. So we rewrite the two equations in such a manner that we put them one below the other. And we can see that if we add these equations, T can be eliminated, because one T is positive and the other T is negative. So we add them and eliminate T. So we get 200 minus 20 equal to 30A. We solve this and we get the value of A as 6 meter per second square. We can use then this value of A in any one of the equations to get the value of T. So I have chosen the first equation, T minus 20 equal to 10A. A is 6, and we solve the value for T, which is 80 Newton. So we have got all the unknowns which were asked in the problem. We have got the free body diagram drawn, we have got the value for frictional force, we have got the value for acceleration, and we have got the value for tension. That's how you solve a problem on connected bodies when one object is placed on a horizontal surface and the other object is hanging.